If we face a piecewise linear function, we can find a linear formulation of that function. The case where our function is continuous can be treated by the techniques that we have seen in a previous video on linear approximations of nonlinear functions. If the breakpoints for the approximation are chosen to be the endpoints of the linear segments, the approximation is identical to the piecewise linear function and we are done. In this video, we will focus on the discontinuous case. The graph shown here is an example of a discontinuous piecewise linear function f. Let k denote the number of linear segments. The domain of each segment I is defined to be a given interval zi, zi prime. Each linear segment is part of a straight line that is described by an expression of the following form. Mi is the slope and bi is the intercept of the straight line. Both are parameters, of course. A linear model works as follows. A binary decision variable delta I indicates which segment of the piecewise linear function is used. When referring to a certain point on the graph, exactly one segment is in use. The x-coordinate within the line segment is a real-valued decision variable with a value between the boundaries of the corresponding interval if that line segment is used. Note that, if a line segment I is not used, the value xi of the x-coordinate is defined to be 0, which is important to keep in mind. For the overall function, the x-coordinate is a real-valued decision variable too that can be derived from the xi values. The function value, a real-valued decision variable, can now be derived like so. This is a linear formulation for discontinuous piecewise linear functions.